Beautiful question. One of my favorite questions. Fine. One of my favorite questions because it looks like there's no approach to do this. Fine. So we need to use a little bit of street smarts, a little bit of textbook methods, understand some algebra, and then unravel this. Fine. So x square plus y square equal to 2025. How are we going to even verify this? How am I going to find out whether there are possible integer solutions to this? And so how are we going to figure that out? How is that going to happen? 2025 is 45 square, which is useful. And if we know that is useful, 2025 is 45 square. It is very nice to see if we can factorize this. 2025 is 45 square. My mind, once I knew that 2025 is 45 square, I've already done this question. This can work. Why? So because this number is 45 square. 45 is 5 into 9. This number is a multiple of 5 square. And so I already know that something square plus something square equals 5 square. I know that. It's a very famous Pythagorean triplet. I know that 3 square plus 4 square is equal to 5 square. Therefore, I know that 6 square plus 8 square equal to 10 square. I know that 9 square plus 12 square equals 15 square. This is 45 square. 27 square plus 36 square should be equal to 45 square. I already know straight away that this appears to be possible. I'm not happy. I'm not going to stop with that. I'm not going to say, hey, done. I don't need to look any further. I'll have to carve open the other things as well. X square plus y square is 2023, 2023. Is that possible? Can that happen? Xy into x minus y is 2021. X square minus y square is 2022. But I know that the first one is possible. I want to see if by some chance something else is possible, in which case I'll have to revisit the first one. Maybe I have done some mistake. Or I want to prove that the others are not possible. When I look at this, 2023 and 2021 are weird numbers. And there is a x square plus y square, which I can't factorize really. But then x square minus y square here, straight away I'm thinking, this fellow I can just factorize and get it done. Right? So this is x plus y into x minus y, which is 2022. That means if I break 2022 into two parts, put one of them as x plus y, put one of them as x minus y, I should be able to solve it and get x and y. Why is it not happening? And so 2022 is 20 into 1011. And 1011 is a multiple of 3. 3 into 3, 3, 7. So it could be 2 into 1011, 3 into 774, 6 into 337. I can write in all these forms. X plus y into x minus y, which means I should be able to solve and get. Except it's not possible because if I put this as 1011, this is 2. If I put this as 2022, this is 1. If I put this as 337, this is 6. What beautifully happens, very, very interesting idea. I have an odd number and an even number and an odd number and even number. 2022 is a multiple of 2, but not a multiple of 4. So 2022, if I factorize it, I cannot write it as a product of two odd numbers. I cannot write it as a product of two even numbers. It will have to be one odd number into one even number. One of the two numbers has to be even, and only one of the two numbers can be even. Which is a problem because if you think about it, if sum of two numbers is odd, sum of two natural numbers is odd, then one of them has to be odd, other has to be even. Sum of two natural numbers is odd. One of them has to be odd, other has to be even. That means the difference also has to be odd. I cannot have a mechanism where sum of two natural numbers is odd and their difference is even. The difference between two natural numbers is even. Either both are odd or both are even. If the difference is even, sum should also be even. If the sum is even, difference should also be even. If sum of two natural numbers is odd, difference should also be odd. If sum of two natural numbers is even, difference should also be even. So if I have x square minus y square, this can be equal to x square minus y square can be equal to an odd number. X plus y, x minus y both are odd. That's possible. It can be equal to an even number, in which case the even number should be a multiple of 4. Both parts x plus y and x minus y should be even. I cannot have x square minus y square equal to an even number that contains only a 2, not a 4. Therefore, this is not possible. By far the most tempting choice. You look at this and say, look, I can write this x plus y and x minus y, I'm through. Right? And then I can simplify, no, except we are not through. We solve x plus y equal to 1011, x minus y equal to 2. Then 2x will be 1013, x will be 1013 by 2. It's no longer an integer, no longer a natural number. Question series says positive integer solutions. Doesn't work. Okay, super. So this doesn't work. These two I still have to worry about. Fine. xy into x minus y is 2021. 2021 is one of those annoying numbers. Right? So not a multiple of 2, not a multiple of 3, not a multiple of 5, not a multiple of 7. 21 is a multiple of 7, 2000 is not a multiple of 7, not a multiple of 11. I'll have to check for 13, 17, 19, all of that. Except I can think of this as 2025 minus 4, 45 square minus 2 square, 45 plus 2 into 45 minus 2. So this can be written as 47 into 43 or 2021 into 1. One of these two has to be this. If I put x into y is 47, x and y can be only 1 and 47, x minus y cannot be 43, out. If I put x into y as 2021, then I have 47 into 43 or 2021 into 1, x minus y doesn't work. Therefore, this there are no solution, this there are no solution, this there is a solution. And so I've kind of gotten to the idea that the first one stands out. I'm very happy. It is just 3, 4, 5 into something. I'm super happy with that because I understand Pythagorean triplets. So this is good. I've kind of established that this is not possible at all, this is not possible at all. Two things that have gone my way. Now let me see if I can prove that this is not possible at all. X square plus y square equals 2023. It's tricky. Right? So I'm going to use any perfect square divided by 4. Remainder will be either 0 or 1. Any perfect square divided by 4, the remainder will be either 0 or 1. Remainder cannot be 2 or 3. Why can it not be 2? Divide the number by 4, if it's a multiple of, if its remainder is 2, then that means the number has a 2 in it, but only 1 2 in it. A perfect square cannot have only 1 2. That's ruled out. So it cannot, the remainder cannot be 2. The remainder cannot be 3 either. Perfect square and divided by 4, remainder is either 0 or 1. If you know that, then it's super easy to simplify. Why? Because I have two perfect squares. They could either have remainder 0 and 0, 0 and 1, or 1 and 1. 1 and 0, again, not worrying about the order. If it is 0 plus 0, remainder will be 0, 0 plus 1, remainder will be 1, 1 plus 1, remainder will be 2. 2, 0, 2, 3 divided by 4, remainder is 3. That cannot be sum of two perfect squares. You can rule that out. That is the more rigorous way of establishing that, hey, this is not possible. These two are easily established that these two are not possible. This is definitely possible. Again, from an exam point of view or a solving point of view, you can just sense that 2025 is a perfect square. It's a multiple of 5 whole square. It is 45 square or 9 square into 5 square. 3, 4, 5 is a Pythagorean triplet. 3 into 9, 4 into 9, 5 into 9 will also be a Pythagorean triplet. And I've got one solution. All I need to do is just have positive integer solutions. I'm through. And then I've established that these three do not have integer solutions, which I can later figure out slowly.